to the computer. Hello, everyone. We're going to do an in-class review recording right now, where we are going to do a practice very similar to what you can expect to see on Wednesday's test. So starting with number 1, we'll identify what is geometric, arithmetic, or neither. Part A. Do you see a pattern in part A? I don't see the same number being added each time, so it's not arithmetic. But I do see a multiplication thing going on. You can type in the chat feature since we're doing a recording. Type into the chat feature what pattern you see for part A. All right, yes, we've identified a ×3 happening from each term, ×3. So we call that our common multiplier. So you would simply say this is geometric because there's a common multiplier. Multiplier of ×3. All right, very good. Okay, we're going to resume recording now. And as we do this, go on to part B. And if you see a pattern, please type it into the chat right now, what pattern you see for part B. Study it closely. Is there a number being added the same each time, or a multiplying number, or no pattern at all? Let's take a look. Yeah, we are adding a -2.5 each time, or you can think of it just subtracting 2.5. Okay, so that makes this arithmetic. And you would write your common difference is equal to -2.5. Awesome. Let's move on to part C now. Go ahead and study that and look for a pattern. Okay, we've identified this one is actually adding by 9 each time, isn't it? So +9, +9, +9. So we're going to call this arithmetic. And D for common difference is 9. If you write the letter D, I know and you know that that means common difference, and that's okay to write. Okay? All right, next, let's talk about simplifying expressions with exponents. All right, number 2. Using our knowledge of properties of exponents. Now, my strategy is typically to work things horizontally and then vertically. So it's a little small, so I'm going to zoom in here so you can see it's a little bit better. But number 2, my final answer needs to be positive exponents only. So I'm going to work this part of the problem first and take everything to the -3rd power. So I'm going to rewrite this right now. Nothing changes on top. But on bottom, everything gets taken to the -3rd power. So that's 2 to the -3rd, x to the -12, y to the -9, and x to the +4th didn't get touched. Okay. Because power to a power means multiply the exponents. So that means anything that has a negative exponent next, like these items, can all be moved. Now, could you combine some terms horizontally first? Absolutely. There's more than one way to do this. But right now, I'm just going to move them. 2 to the +3rd. I'm going to put that next to 2 to the 1st. That's already up top. X to the +12, right next to x to the 4th. My 4s look like 9 sometime. There we go. Make this longer. Y to the +9th, right next to y to the 2nd. And all alone on bottom is x to the 4th, right? Okay, do it. Okay, so we're going to cancel x to the 4th over x to the 4th. And we're going to combine stuff a little bit more. 2 to the 3rd and 2 to the 1st equals 2 to the 4th power. I'm going to cross them out as I do them. X to the 12th is just by itself. And the y's combined to y to the 11th. Final answer, I'm going to calculate 2 to the 4th power, which is 2 times 2 times 2 times 2. That's 4 times 2, that's 8. 8 times 2 is 16. So 16, x12, y11. That's going to be my final answer here. I'm going to pause right here for questions. Part B, we're first going to do that power to a power property. So you can even kind of like draw the distributed property arrows if you want to remind you. So we'll have 2 to the 3rd, x to the 3rd, y to the 6th, times 3 to the 2nd, x to the -4th, y to the 2nd. So let's turn this into 2 to the 3rd, 3 to the 2nd, x to the 3rd, x to the 4th, -4th, y6, y2. And the reason I do that is so now I can combine like terms, so to speak. The x's can combine. Same base, you're multiplying, so you're going to add the exponents. That's x to the negative first. The y's can combine. Same base, keep the base, add the exponents. That's y8. Now those have different bases, so you can't combine these. These are just two numbers that we're going to multiply out. 2 to the third is 2 times 2 times 2. That's 8. And 3 to the second is 9. So let's simplify this one step further. That'll be 8 times 9 is 72. Y to the 8th is on top. And what happens to that x to the negative first? Where does that go? Underneath as x to the positive first. You don't need to write that 1. You can just write x, just like that. All right, in number 3, we have to do a couple things. Identify the pattern, identify it as arithmetic, geometric, or neither, write the explicit and recursive equations, and find the 100th term. So there's 4 parts to these, okay? So let's get going on part 1. Identify the pattern. So these are all going up by 1, so that makes this pretty easy for us. These are taking away by 3, so minus 3. We have a common difference of negative 3. So that's our pattern for part 1. Part 2, since there's a common difference, that makes this arithmetic, right? Part 3 says, if it's arithmetic or geometric, write both forms of equations. So I'll write E for explicit. So we've got T of n. It looks just like slope-intercept form. So we've got negative 3 times n plus T of 0. Now, if I work my pattern backwards to the 0th term, I'm going to be sitting at positive 7. So that's my explicit equation. R for recursive means what is the next term in line? This is pretty basic. The next term in line is the current term plus your common difference or take away your common difference. And as you also need to list the first term, which would just be 4. So that's number 3, both equations. In number 4, or part 4, find the 100th term. Use the explicit equation to find the 100th term. Plug 100 in for n and multiply negative 3 times 100 plus 7. And you'll get the 100th term is negative 293. That's your 100th term of your sequence. Pause here for questions. Part B, do you notice a pattern? Type it into the chat what pattern you notice for part B. Recording here. All right, so number 1, what pattern do you see? And a lot of people said divided by 4, but let's think multiplication. So we're going to say times 1/4 is our pattern. And part 2, that makes this a geometric sequence. Okay, which takes us to part 3. Come up with both forms of equations. So the explicit form of a geometric equation looks like this. It looks like an exponential function, like that. But instead of y, we use t of n. A is our t of 0. It's our y-intercept. So if we work this pattern back one time, if we multiplied by 4, that would be t of 0. So we got to do negative 64 times 4. So what would that come out to be? 64 times 4. That's 256. So that's your 0th term. Times your multiplier. Yep, sneak our negative sign in there. Thank you. Times our multiplier of 1/4 to the power of n. So that is your explicit equation right there. It's your 0th term, your multiplier to the power of n every time. Now your recursive equation looks just like the previous one. It's t of n plus 1 equals t of n. Instead of plus a number, it's times your multiplier, so times 1/4. And then you list the first term as well, negative 64. So now we move on to part 4, which says find the 100th term in line. So to get that, it would be best to use our explicit equation, plug in 100 for n, and calculate on your calculator what you would get when you do 1/4 to the 100th power times negative 256. Go ahead and calculate. Okay, now think about it. If you're going to multiply by 1/4 100 more times, you're going to get a very small number. In fact, it's so small, your calculator is going to give you a scientific number, scientific notation. So we're going to round this. I got negative 1.59 times 10 to the power of negative 58. That would mean you move that 0 58 times to the left. That's how small this number is.